We're at gotomath.com. That's where you should be if you're watching this stuff. We're going to be doing differentials, and it looks like we are doing number 1-1. Okay, so if you've never seen this stuff before, hang in there. It may be kind of abstract. I think the more of these differentials, this concept, the more different things you work, the better off you'll be. Let's see, we got 5x squared. X is equal to 8. Delta x we're going to consider equaling dx. That's the differential of x. And 0.1. Okay, it says round delta y to 4 decimal places. Okay, let's go over to the whiteboard and write some of this stuff down. So we have y is equal to 5x squared. X is equal to 8, and delta x equals the differential of x, that's how you say that, is equal to 0.1. Okay, now they're asking us to compare delta y. We want to compare delta or differential of y to should be approximately equal to delta y, and delta y was the change in y, okay? So let's write down, for example, I'm going to take the derivative of this, and the derivative of this is delta y is equal to dx. Dy over dx is equal to 10x. So you remember this notation. So here's a good reason why we use this notation. So I'm going to solve for delta y in this problem, and we end up with delta y is equal to 10x dx. So that's how we're going to derive up our delta y. Okay, that was pretty easy. Now we want to derive up our change in y, and the change in y, remember, came from, remember we did finding the derivative using the definition, x plus delta x minus f of x. Okay, so this is what our change of y is actually equal to. Now what we can do is go ahead and plug in our numbers, and let's just do that. And you know what, let's just continue that one straight over like this right here. Okay, so we have delta y is equal to 10x is 8, and dx is considered to be 0.1. Alright, and then we can get our handy dandy calculator out. Let's see, that's 80, and that's 1/10 of 80. Wow, we should be able to figure that out, right? In our brains. That's pretty simple. I'm getting 8 on that. Okay. And then this one here, we'll continue this right over here. So change in y is equal to, actually, you know what, we're going to do a few things here before we do that. So x is 8, or delta x is 0.1 minus f of 8, right? And so this becomes f of 8.1 minus f of 8. Okay, so let's plug in 8.1 into the function here. So we end up with 5 times 8.1 squared, that would be this one, and then minus 5 times 8 squared. Okay, pretty simple. And then let's go ahead and just get this and put this down here. So 5 times 8.1 quantity squared minus 5 times 8 squared, and we get 8.05. So as you can see, delta y, or the differential of y, which is 8, is approximately the change in y, which is 8.05. Okay? Of course, these squiggly lines mean approximately. This is approximately this. Okay? Now that's all I want you to know. Alright? What we're doing, what's going on here. Don't think any more deeper into that. Alright? Remember, this is change of x, differential of x, differential of y, and change in y. Okay? Alright, well, let's go back to the web page and let's make sure that, let's see, and it said round delta y to 4 decimal places. I guess we should say if needed. Okay, so I probably need to change that because that was exactly 8.05, so I'll have to go in there and change that. But anyway, as you can see here, dy is equal to f prime of 8 times, now remember we took the derivative, that's what this is indicating here, and we plugged 8 into it, and then this is our dx, right? And then of course what the delta y is equal to. Okay, so that's all you need to know about that. Think any more else about it. Alright, so remember, we're over here at gotomath.com, and you'll want to come on by and practice this stuff, and maybe I shall chat with you there if you need some help. Alright, bye.